Today we're going to be analyzing how to sketch rational functions, taking up this example of the f of x is equal to x minus 2 times x plus 3 divided by x minus 3 times x plus 4. When we first to begin to sketch a rational function, we must find these attributes of it. Its holes, if it has any, its vertical asymptotes, if it has any, its horizontal asymptote, if it has any oblique asymptotes, if it has any, or in other words, a slanted asymptote, its x-intercepts, and its y-intercepts. These are key points that we must find for a rational function in pre-calculus. This is required and will be tested upon, so it is important to master how to find these attributes. Very important. To find a hole of a function, we must see are there any values that are non-defined within our current function, which we can redefine by modifying our function or redefining it. In this case, we cannot redefine x minus 2 times x plus 3 divided by x minus 3 times x plus 4 to get our discontinuities of when x is equal to 3 and x is equal to negative 4. Hence, there will be no holes within this rational function. For our vertical asymptotes, we simply find what quantities of x once substituted into our variable or get the denominator into 0, because when the denominator is equal to 0, this function will not be defined, as for a rational function and for any ratio in general, the denominator can never be 0. So when x is equal to 3 and when x is equal to negative 4, the graph will not be defined and will reach positive or negative infinity, hence resulting in our vertical asymptotes as x is equal to 3 and x is equal to negative 4. The trick is, if you have not already picked up, to find the values of x to make the denominator 0. The horizontal asymptotes we can find by simply looking at the largest powers coefficient in the numerator divided by the largest powers coefficient in the denominator and forming a ratio out of the two. So the coefficient of the largest power in the numerator will be x squared, with that coefficient being 1, and the coefficient of the largest power in the denominator will be also 1 with x squared, hence resulting in our horizontal asymptote to be y is equal to positive 1. Our oblique asymptotes will not have any, as we already have a vertical and horizontal asymptote, so this will be none. And for our x-intercept we can simply find when what quantities of x will make the numerator 0, and those quantities will be 2 and negative 3, with our y-intercepts being the intercept in the y-axis, which we can find by simply substituting 0 into our x variable, and that will get us negative 6 over negative 12, which will be equal to 1 over 2. So that will be our y component for our y-intercept. So the y-intercept coordinate will be 0, 1 over 2. Now we can plot these attributes onto our coordinate system. So we can first draw our vertical asymptote when x is equal to 3, right here, and our vertical asymptote when x is equal to 4, right here. It's not drawn well, it has to be very straight, like that. And then we can draw our horizontal asymptote when y is equal to 1. Will look like that. And our x-intercept points, the special points within this rational function, will be 2, 0 and negative 3, 0. Our y-intercepts will be 0, 1 over 2. So that'll be right here. And now we can begin to find this, what this might look like. To start, we can first look at when x approaches x is equal to 3 from the right hand side. So it's going to infinitely get closer to positive 3 from the right hand side, introducing the concept of a limit. Limits come in very important when graphing rational functions. And a point that's very close to 3 from the right hand side of it will be 3.01. So we can first substitute x is equal to 3.01 to determine whether when it approaches 3 will be positive infinity or negative infinity. When x is equal to 3.01, the numerator will be positive and the denominator will likewise also be positive. A positive outcome divided by another positive outcome will result in a positive outcome overall. So our function will approach positive infinity as it gets closer to x is equal to 3. And when x is equal to 6, more further away from 3, the resulting outcome in the numerator will again be positive and the denominator will again be positive. So by maintaining this restriction and maintaining the restriction of never passing through this horizontal asymptote of y is equal to 1, it will come down and infinitely approach y is equal to 1. That will be our right hand side's graph. Then we look at this center portion right here. To determine that, we must introduce the limit again, and for our limit, when x approaches negative 4 from the right hand side, so let's do another quantity for x being negative 4.01. The resulting outcome for our numerator will be negative instead of positive. So it'll be negative, and our denominator will be a negative and a negative to become a positive for our denominator, for our denominator, sorry. And a negative outcome divided by a positive outcome will result in a negative total outcome. So it will approach negative infinity as it gets infinitely closer to negative 4. And then it will bounce back up to touch, or pass rather, to pass, not touch, to pass 0, 1 over 2, because everything here is to the first power. So it'll only be a pass, not a touch. And then it'll continue to go maintaining that same direction, getting very close to y is equal to 1, then come down again to hit 2, 0, our second x-intercept. And since x minus 2 will be a pass, it will have to continue going down in that same direction, that second before it touched 2. And we can verify this by finding a limit for when x approaches, let's say from the left hand side, 2.99. When 2.99 is substituted, the resulting outcome in the numerator will be a positive, but the denominator will be a negative. And a positive outcome in the numerator divided by a negative outcome in the denominator will result in an outcome of a negative quantity, hence going down and infinitely trying to reach x equal to 3 and going to negative infinity. And then for our left hand side, if it doesn't already seem obvious, we know that it cannot touch the x-axis anymore because we only have 2 x-intercepts. And since it has to be within the bounds of the asymptotes, it can only look like this. We can be sure of this by taking the limit when x approaches negative 4 from the left hand side, such as negative 4.01. Negative 4.01 substituted into f of x will result in a negative quantity in the numerator, and it will result in another negative quantity in the the denominator, or positive rather. Yeah, positive divided by a positive will result in a positive. So it will always remain within this upper half region of the x-axis because only there can the terms of x be positive and the y values correspondingly. So this is how you roughly sketch out the rational function of x minus 2 times x plus 3 divided by x minus 3 times x plus 4.